What's up, fam? We're doing AP Calculus AB 2025 for response question number 2. The shaded region R is bounded by the graphs of the functions f and g, where f is the x squared minus 2x. That's our parabola over here. And g of x is x plus sine of pi x. That's our little wavy line function over here. Continuing on, it shows us that it intersects at 0 and 3, which interestingly enough is going to mean that our limits of integration here are going to be 0 and 3 throughout all of our dx questions, and 0 to 3 for dy, not as much if we had the slice through, so hopefully it's only dx's here. Find the region, find the area of R, show the setup for your calculations. That is what letter A here says. Find the region of R, show the setup for your calculations. So if you're going to find the area of R, let's go ahead and answer letter A. We can answer it right here. The area of region R is going to be equal to, it's going to be equal to an integral. And anytime you're finding an area, you always want to make sure you're doing a top minus a bottom or a right minus a left. In this particular question, like I was saying before, you really don't want to go left and right on this one because it would cross through the same function multiple times. And anytime you cross through the same function multiple times, we don't really have functions, we have issues. So we don't want to do any dy's, we're going to be doing dx's. So we have an integral from 0 to 3. Let's draw one of those dx rectangles in. There we go. A beautiful dx rectangle has been drawn in there. And we can clearly see that the top one is going to be g of x. The bottom one is going to be f of x. So top minus bottom. Then we put our dx in there. You can't see what I wrote there. If you want to be fancy with it, put brackets around your g of x and your f of x. You don't actually need to do that. But then after that, you do need to plug these bad boys into your calculator. Now, this is a great tip. Whenever you have a question like this, we're going to use the same function over and over. Go to your y equals screen first and type those functions in. So we did learn that f of x, our first function, our bottom function, is going to be x squared minus 2x. And then there's also going to be the top function, g of x, x plus the sine of pi x. Where's my sine button? Sine of pi x. They're also nice enough to remind you, hey, your calculator's got to be in radian mode. Well, mine is, so we're good to go there. And the reason why I typed that in is now I can type this integral in exactly as it appears, remembering that I made this one over here my y1, and I made this one over here my y2 when I plug it into my calculator. And then if you're actually doing that, you probably want to slice through that when you're actually on the AP exam, because you don't want them to grade that. If you put a single line through something like that, they won't grade it. So you know it, but they can't look at it. So now we're going to go ahead and use our integral button, the integral from 0 to 3 of our y2 minus our y1. So y2 minus y1, and dx is going to be what we're dealing with there, and we end up getting 5.1366, which will round to 5.137. Beautiful first answer. Let's move on to part B. Region R is the base of a solid. For the solid, each x at the cross-section perpendicular to the x-axis, so we've already drawn one of those, is a rectangle with height x. So we have a rectangle coming out of this thing, like so. So there's my representative rectangle that is coming up out of the page. I know it's hard to tell that in 2D, but that's what's happening. And basically the height is going to be equal to x, so that this length here is x. Anytime you're finding a volume that is using a box like this, you want to remember we'll have the length times the width times the height. And we're doing this in integral format with a dx as one of our variables there. And that's going to be our width. It's going to be our dx. So our answer to part B here, which we're going to be able to answer it, our volume of this solid, the volume of this particular cross section is going to be equal to the integral from 0 to 3 of our length. Our length is that same top minus bottom that we had before, g of x minus f of x. Our height, we were told, is x, and our width is going to be dx. So it's almost exactly the same setup as the previous one. We just kind of threw an extra x into there to make our volume complete. And we're going to use our tricks on the calculator to make that happen as well. We're going to go up here. We're going to go ahead and insert a parenthesis there, insert a parenthesis there, and insert an x right there. Boom. We have looks like to be 7.705 as our answer to letter B. Letter C, write but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated about the horizontal line y equals -2. So let's go ahead and draw that line in. Y equals -2, we're drawing it in. And we're taking this object and we're twirling it around the axis. So if you notice here, we're going to start this guy right here and we're twirling that around the axis to make a perfect little circle. And this one down here is also being twirled around the axis to make a perfect circle. And we can see our beautiful representative washer when we've drawn that in there. Anytime you're using washers, you want to remember your generalized formula, pi integral r squared minus little r squared. And that's your generalized formula where you have a d something, and that d whatever lines up with the limits of integration, whatever you're doing. So for this part C here, I think I'm going to write my answer down here for part C. I don't want to write it right there. It's a little bit too small. We have that pi out in front multiplied by the integral of the big radius minus the small radius summed up over the entire thing. So our big radius is that function on top, g of x, but don't forget, you have to remember that this is +2. It's g of x, and then there's the additional value of 2 added to it, because like g of x is like this length right there, and then 2 is this length right there. In general, it's top minus bottom. G of x minus -2 is g of x plus 2. So we have our big radius, g of x plus 2 quantity squared. Don't forget we're still from 0 to 3. Now we subtract our small radius. Now our small radius is also going to be with that plus 2, except now it's going to be f of x plus 2. Don't forget you're squaring it, putting that dx out there. We have all kinds of stuff going on over here. Now, what's interesting about this is when you end up doing the entire thing, the +2s are actually going to end up canceling out completely. So if you had forgotten to write them down, you actually would have ended up with the same exact answer. So you have to have them written down, though, as part of your correct solution to this problem, because you have 4 minus 4. It will end up canceling out. We're still going to type it into our calculator to make it look official and whatnot, because we have this entire thing, and now we simply type it directly into our, we don't even have to. It says write but not evaluate. We're done. Beautiful. We don't even have to type it into our calculator. It can be shown that g prime is equal to pi times the cosine of pi x. We know this. Find the value x for x between 0 and 1, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. So for part D here, we're definitely going to need to show a little bit more work, because we're going to need to take f prime here. So f prime of x, we're taking our derivative. We have 2x minus 2, and you're trying to show where the two derivatives are the same. That is, you're trying to show where they are parallel, where f prime of x is equal to g prime of x. And now we need to figure out the value that is in between 0 and 1, where this is a true statement. So our f prime is 2x minus 2. Our g prime of x is going to be 1 plus pi times the cosine of pi x. And this is just a nasty looking thing. Anytime you have a nasty looking thing like this, you're just basically just trying to get x alone. Is not going to be an easy process. But what you can do is use graphing methods. You can use your graphing calculator to figure out where this is true. So that is exactly what we're going to do. We're going to go ahead and go into our calculator and graph these two functions. We don't need our originals anymore. We need the 2x minus 2, and we need the 1 plus pi times the cosine of pi x. There we go. And now we're going to go ahead and change our window. We only care about the window between 0 and 1. And in addition, for that window in between 0 and 1, it should be, I cannot speak, for the between 0 and 1, it's not going to go very high. It's not going to be crazy big. So I think -6 to 6 is fine. We're going to hit graph. And where does it cross? Where do these two things meet each other? They appear to meet each other in exactly one spot. It'll be nice and easy to just go ahead and use our trace feature, our intersection feature, to figure out where that is, first and second, and guess. There it is. And it turns out it's at 0.676. is what this ends up being. So after some algebra, we get approximately 0.676. This might be the end of the video. I'm going to pause super fast. Yep, that's the end of the video. Have a great rest of your day, guys. Peace out.